Hello students, welcome to Misostudy and welcome to my class. Today I am going to discuss some formula related to thermodynamics. Clear? This is just a formula class. I will take only 10 to 12 minutes. I know 10 to 12 minutes is not sufficient. Still I will try to cover maximum number of topic for you. Yes. The topic here is thermodynamics. What is thermodynamics? The branch of science, the branch of chemistry which deals the thermo, that is heat. Dynamics means the flow of heat. Clear to you? Flow of heat known as thermodynamics. Now, heat flow from system to surrounding and from surrounding to system. Clear? Yes. System, the types of system, first of all we know open system. Yes. The second one is closed system, and the third one is isolated system. Open, closed and isolated system. Except these two, most systems are there. First of all, that is homogeneous system. Yes. The second one is heterogeneous system. Homogeneous system and heterogeneous system. We have two systems, that is homogeneous and heterogeneous system. Clear to you? Yes. We know isolated system, in which there is no transfer of matter as well as heat take place with the surrounding, is known as isolated. No system is completely isolated. Okay. Now we have two more properties, that is intensive properties and the second one is extensive properties. Intensive properties and extensive properties, the properties which does not depend upon the quantity of matter. Again I am repeating, which does not depend upon the quantity are known as intensive properties. The properties which depends on the quantity of the matter, quantity, that is known as extensive property. For example, we have mass, we have volume, we have free energy, gives free energy, we have internal energy, enthalpy, entropy. These all are, that is intensive extensive property, that is depend upon the quantity. Now if anyone asks you what about the intensive but does not depend upon quantity, is a very good example: melting point, boiling point, temperature. Clear? Viscosity. Clear to you? Yes sir. Mole, percentage by mole, or best one is force, pressure, sorry not force, force is extensive property, pressure, force per unit area is, pressure is the intensive property. Then there come density, mass per unit volume is intensive property. One more thing, if we add two intensive property we get intensive property. If we divide two intensive property we will get intensive property. If we multiply two intensive property we get intensive property. Now extensive property, that is if we add two extensive property we get extensive property. If we divide two extensive property we get intensive property. That's why pressure is force upon area. Force is extensive and area is also extensive property, but pressure is intensive property. Okay. Now we have thermodynamic parameter moving here, that is thermodynamic parameter. What is thermodynamic parameter? The parameter will decide the state of a system, which decide the state of a system, like temperature, pressure, clear to you, concentration, enthalpy. These all are treated as a thermodynamic parameter. Clear to you? Yes. Now we have the next point is work. Work done is equal to F into dx, we know. And in case of chemistry, that is P into A, force equal to pressure into area, A into dx is equal to delta V. So work done is equal to P delta V, or dW is equal to P dV. This is the work done. Yes sir. Now extender form we can write work done is equal to minus P external delta V. P external delta V, that is V2 minus V1. Am I right? Yes. Now, if work is done on the system, that is positive. If work is done by the system, that is negative. If work is done on the system, it is positive. If work is done by the system, it is negative. Now, heat, we know Q is equal to ms delta theta. Theta is the temperature change. Okay, ms delta theta, theta is temperature change. If heat is given to the system, that is positive. If heat is out of the system, that is negative. Clear? Yes. Now, work done, work is a path dependent function. Path dependent, that is area under the graph gives you the work done. For example, suppose this is a PV graph and area, this is area under the curve, gives you the work done. This is PV, area under the curve gives you the work done. This is the area, work done. Clear to you? Yes, work done may be positive, may be negative depending upon the situation. Now, what is internal energy? Internal energy, the total of all possible kind of energy present in the body is known as the internal energy. Change in internal energy U2 minus U1. Internal energy may be positive, internal energy may be negative. If U2 is greater than U1, then internal energy is positive. If U2 is less than U1, then internal energy is negative. Clear to you? Yes. Now moving. Okay, now there comes enthalpy. Enthalpy, that is heat content at constant pressure, that is H is equal to U plus PV, or delta H is equal to, directly we can add delta U plus delta NGRT. Yes, this is the heat change at constant pressure, this is the heat change at constant volume. Delta Ng, we know number of moles of gaseous product minus number of moles of gaseous reactant. Clear to you? Delta H may be positive, may be negative. If delta H, generally delta H comes positive, then the reaction is endothermic. If delta H comes negative, then the reaction is exothermic. Again I am repeating, if delta H is positive, that is endothermic. If delta H is negative, then the reaction is exothermic reaction. Clear? Yes. Now heat capacity. Heat capacity at constant volume at constant pressure, Cp and Cv. We know Cp upon Cv is equal to gamma. Gamma is the atomicity of the gas. If gamma is equal to 1.66, the gas is monoatomic. Yes. If gamma is equal to 1.40, the gas is diatomic. If gamma is equal to 1.33, then the gas is polyatomic. Clear to you? Cp upon Cv is equal to gamma, and Cp minus Cv is equal to R. Clear? This is the relation we have. Yes. Now first law of thermodynamics, that heat can energy can neither be created nor be destroyed. Mathematical form, we know delta E is equal to Q plus W, heat and heat flow to the system and work done on the system. If work is done by the system, then it is Q minus W. Clear? This is the mathematical relation of first law of thermodynamics. Yes. Now work done in isothermal reversible expansion. What is the expression? W is equal to minus 2.303 nRT log V2 upon V1, and work done is equal to minus 2.303 nRT log P1 upon P2. Minus 2.303 nRT log P1 upon P2. Now this is the case of expansion. Again I am repeating, this is the case of expansion. In case of compression, what happens? Yes, in case of compression, work done, this is isothermal reversible expansion. Okay, the work done is equal to minus 2.303 nRT, this come plus log V1 upon V2. Clear to you? Yes sir. Or 2.303 nRT log P2 upon P1. Clear? Now we have isothermal, isothermal irreversible expansion. In isothermal irreversible expansion, work done is equal to minus P external dV, or you can say delta V. Clear? Yes sir. Now we have entropy. Entropy is the degree of measure of randomness. Entropy change delta X is equal to Q reversible upon T. For isothermal process, entropy is equal to 2.303 nR log V2 upon V1. These are the general formula we use. Okay, now what we have, spontaneous process and non-spontaneous process. The process which happens without the help of any external agency is known as a spontaneous process. The process which happens due to the involvement of an external agency is known as non-spontaneous process. Clear? Spontaneity is decided by the decrease in energy or increase in the randomness. These two factors completely govern the spontaneity of a reaction. Clear to you? These are the simple formula. In thermochemistry, generally use heat of the reaction, that is delta H is equal to product minus reactant. Here delta H in thermochemistry, that is HP minus HR summation, or delta H is equal to, you can say, summation of, then summation of this one. Clear to you? Yes. Now Hess law, that is if process complete in one step, or if a process complete in two steps, then overall heat, suppose in this case delta H1, this case delta H1 and delta H2. So overall delta H is equal to delta H1 plus delta H2. This is the heat change. Clear? Yes sir. These are the things generally we observe. Generally we observe in case of thermodynamics. This is not enough, just I am giving you an idea about thermodynamics, and practice the maximum number of questions, practice the theory, or follow my regular lecture will help you all that. Now my friend, time has come, time to say bye bye. Thank you so much.